And I was repeatedly using the term mobile sites versus desktop sites. My son in the audience, my son is 15, in the audience was white. At the end, he approached me and said, "Dad, but why you insist on calling that mobile? Mobile is a tablet, is a smartphone, is your phone," my phone, which is not even a smartphone. It's not mobile. They are so different. You cannot call them mobile as they were the same kind of thing. Right. Absolutely right. So the title of this talk is Building Websites for Multiple Devices, not just one. But developers, we are not scared of working long hours, but we are, however, scared of not looking smart when we do things. And this is, the fundamental issue why we, in my humble opinion, insist on not taking not trying to tame the devices beast the right way. We want always to do things that make us look smart. So we think, why should we have 3, 4, 5, 6, 7 different views to target maybe smartphones, tablet, smart TVs, PCs? Why multiplying views? Why wasting time and resources on devising the most efficient, usable way of presenting content on a variety of different devices when we can just be smart? Write one set of HTML pages and then use the browser. The browser ability to switch CSS files on the fly, that magical feature called CSS media queries, which is great. It's a fantastic feature. It's much, much better to have than not. I wish we could have media queries 10, 15 years ago instead of just now. But anyway, we think smart. I can take advantage. I can turn the browser's ability to my end and just write one set of pages, just apply different CSS, and magically, and also really, it's not, I'm not trying to make jokes. It's true that one set of pages via the application of different CSS files that the browser does automatically. So you only have to specify which CSS you want based on the width of the screen. That makes automatically the site to resize and reflow the content based on the width of the screen. Now, responsive web design was not devised to work on mobile devices, for mobile devices. It's a desktop technology. But it is so smart, and that's why we love it. It's so smart that it takes into account the width of the screen, so it can magically work regardless of the device that is where the browser is running. So as long as it knows that the width of the screen is 400 or 480, whatever, or 800 pixels, so the typical size of a smartphone or tablet, it just adapts the content to that width, regardless of the device. Wow. That's smart, and we love to be smart. But on the other hand, I say, you are here, and I can roughly count 70 more people here today, this morning, at 8:30 in the morning, with so many other things to do in the gray Darmstadt. Okay, maybe it's better he'd be here. Anyway, I wonder, why are you here today? You are here because you probably, I presume, are interested in learning how to, which are the options to build websites for multiple devices. And why on earth people buy different devices if then we developers boil it down to just provide different CSS for one view? So it's a contradictory. It's a contradiction. We want to serve. We want to be nice. We want to show ourselves, we are effective and efficient to people by, hey, look, no matter which device you have, my software, my website can be used effectively on whatever device you have now and in the future. Wow. And then we say, how would you do that? Wow, you look magic. You're a wizard, you're a magician. How can you do that, this kind of magic? Oh, don't worry, I don't care about your device, actually. I'm just using the same set of HTML pages, and the browser will do the rest. It's a contradiction. This doesn't work. Now, you want to be smart, fine. Is performance important for you? Now, I don't really know, and I couldn't care less of the exact numbers in the industry that monitor, the traffic that goes, the internet traffic that goes through mobile devices and desktop PCs. But I guess it's a rough guess, but I'm sure I'm not really far from truth that they are 50-50. But the trends are different. The desktop is going down, the mobile traffic, the device-based traffic is going up. That's for sure. So it's extremely key, fundamental issue today that we at least learn the tools or the options at least. The challenges that we have to face, the key issue we must be aware of to target effectively multiple devices. But there are, when it comes to mobile things, quite a few misconceptions. The first one is, oh, don't worry, my site is good enough today on mobile devices. Again, my son, another personal anecdote involving my son. We went to a charity event, and at the end of the presentation, a guy who called himself the CTO, or sort of the organization, wanted to take a few moments to present their new website. And he claimed, this website works also on your iPad. And also on your iPhone. Wow. My son tried instantaneously. All of the kids in the room were trying to, on their phones, iPhones in some cases, the site. And all they could find out was that, yes, you could see the website on the smartphone. Just see. It was just displaying. So you could see that there were a page that could fit into the 4-inch screen of the smartphone. Again, my son, not because he's my son, because of his mother probably, was quiet enough, was able to stay quiet enough during the presentation, but he couldn't resist off records. So he went up to talk to the CTO of the organization and said, look, but what do you mean by your website shows up through my iPhone? You mean just that I can see it? No, you can use it. No, I mean, one thing is that I can see the website through my smartphone. It's a different thing that I can use it, because I cannot click on any link. To read, I need to continuously pinch and zoom to make sense of what kind of content you have there. So my site is good enough on mobile devices. Well, it's a statement that needs to be taken carefully. What do you mean exactly by good enough? That you can only see it, or that you can really use it? And then mobile users, oh yeah, they think they are. They know they are unfortunate. They are poor guys on the face of their heart. They expect pages to be slow. So why should we care about that? Why should we invest time and resources? Why we have, just to paraphrase Scott Anselman, we have a finite number of pricks left in our careers to waste them to make mobile software, smart. Mobile users expect pages to be slow. They are fine, they're good enough. But this is a point we could be missing, business-wise. I mean, I don't want to look like the Cassandra, the woman in the old mythology, Greek mythology, who was famous for saying bad things that eventually happened. I don't want to be the Cassandra here, but well, the trend is apparently, is fairly clear and well defined. Devices, the use of devices is definitely going up. So that means that it will come a time, my guess is 2 years, in which it will be absolutely unacceptable for every user to go on a website that is not fully enjoyable through whatever device, and especially small devices. So this means that, okay, mobile users expect pages to be slow. Yesterday, maybe today, not certainly tomorrow. So it's really important that we try to address usability and performance, because the two things on mobile devices go together. Oh, don't worry. We provide an app for that. Yes, an app for that, but there's a difference between having a native application and a usable mobile site. An app is a different thing. You can have both, sure. Or you can only have an app and just have a... It depends on the business, depends on the scenario. Probably if you are Instagram, you don't need a website at all. And in fact, the Instagram website is pure crap. They don't need it. They just need to have nice, well-done apps. But if you, I don't know exactly what kind of business do you do, but I can guess that most of you come from sort of enterprise world. So I believe that in an enterprise scenario, whatever that means exactly, the site still remains a fundamental asset, and an app is something just icing on the cake. And also, don't forget that you write the site once to reach a variety of platforms. An app needs to be done potentially for several platforms. And that really multiplies, no matter PhoneGap, no matter Cordova, no matter commercial products, no matter Xamarin. It's still a matter of multiplying efforts per platform. The variable thing is the size of the multiplier, but the multiplier is greater than 1. Mobile users only care about doing things. So it doesn't really matter the speed at which they do things, as long as they could do that. You are, if you think so, you are undervaluing users. Mobile users love to pinch and zoom, as long as it's the only option they have. We'll provide an app. Yeah, I already, addressed a couple of these points. How many apps? Don't forget that the web is device neutral. And how do you write them? Native apps, Objective-C, Java, maybe C# if you're lucky with Xamarin. It's, again, a matter of really multiplying effort, and the factor is greater than 1. And still, don't forget that even though Xamarin, and I love Xamarin tools, I do use Xamarin tools, they do a great job, but there is, at the moment at least, a boundary that they cannot trespass. As far as I know, they're working around that, but it will take probably more time. for them to incorporate and to minimize, to smooth also the application of effective user experience practices to cross-platform mobile development. Because what you can do now is essentially, if you take the hybrid web way to cross-platform mobile development, PhoneGap, Cordova, and commercial products, you essentially choose the common denominator of a web-like interface. So your interface is not specific, is hardly specific of iPhone, Android, or Windows Phone. Yes, via CSS you can do a little bit of magic, but it's continuously, I mean, to me it looks like a patched solution. So my approach is trying to go native whenever it's possible, is reasonably possible, trying to minimize via, the only option is Xamarin, the effort it takes to write the code, to try to reuse as much as possible the source code by using the same language and portable class libraries, wherever it works and wherever it's possible. But one thing that today you can hardly reuse, you can reuse the logic, the presentation logic part of. You can certainly reuse the application logic. You can definitely reuse the business logic, which lives for the most part anyway on some server. You can hardly reuse the user interface and part of the presentation thing, because Android requires, if you want to really look native, specific widgets, which are similar but not the same as those you find in iOS, different from what you find in Windows Phone. Okay, and that's it. User experience can probably, for the time being, need to be rewritten every time. So it's not, we provide an app, but it takes a lot more work than the web channel, which is neutral to devices. My site is good enough on mobile devices, yes, but do you really know about the thing called latency and the thing called connection to the network? Latency defined is the interval that elapses between the request and the response, and it could go up to 300 milliseconds. Similar things can be said for the connection, which on 3G can be up to 15 times slower than Wi-Fi. More importantly, you have no control over these things. At the best, you can detect the type of the connection you're having. But doing that from a native application, well, there are APIs for that. Over the web is far more complicated. And the result is that you just ignore the problem of slow connections and latency that make the connection, the experience slower. Results is that you probably serve slow pages to users, but who cares? Mobile users are good, are used to have slow pages. So two steps for a strategy that can help us addressing the challenge of mobile. Number one, my opinion, again, humble opinion, is make sites accessible, really accessible to devices, which essentially means recognize that device, at least the class of the device. I'm not talking about knowing exactly whether it's an HTC, whatever it is, or a Vodafone, whatever it is, or a Samsung, whatever it is, just the class. Whether it's a smartphone, it's a regular phone, it's an old legacy phone, it can just make phone calls, it's a tablet, mini tablet. I mean, the granularity is up to you ultimately. But just the class of device, that's important. And don't forget what's coming up. So we normally focus on smartphones, tablets, PCs. Okay, maybe legacy phones, just old phones with nearly no capabilities other than rendering some HTML. But there are two other guys at the extremes of the axis that are going to appear. Wearable devices, very small screen and very special screens, Google Glasses, for example, but watches and other things. And at the other end, very large screens, smart TVs, Xbox. These are devices. Now, the current mainstream methodology for addressing the different varying sizes of screens, responsive web design, says that no matter the physical type of the device making the request to your website, as long as you know the width of the screen, you're happy, because with CSS you can stretch content. But that's the point, stretching like this or like this, content. But it means that you need to have one content, that fixed content that you can stretch. And how would you choose this content? So it means that you have to target one primary class of device, one default size, optimize the content for that size, and then stretch it in both directions, for small and for large. Typically, you optimize for the desktop. So 1,000 by, typically 1,000, about 1,000 something width. But those who claim they do mobile first optimize for smaller sizes. But it's smart and silly at the same time, the mobile-first approach. Think about that. I mean, it's silly if you claim that a content optimized for a small screen, mobile first, can be scaled up to the size of the desktop, and even worse, up to the size of a smart TV. Unless you're a big fan of Windows 8, which is famous for having large screens and just a bar of content like this in the middle, and everything else is empty. If that is your ideal, fine. But otherwise, think about that. The content is essential. We have websites to deliver content, and it's at least silly if we claim we can have the regular website with small content that we can stretch also to the size of 2,000 pixel widescreens. But it's also mobile first is a smart idea if you completely change your idea of the website and you make the transition from the regular ASP.NET web forms or MVC classic, request response website and move towards single page applications. JavaScript intensive client-side websites. That's different because in that case, mobile first makes sense. You optimize, you start designing with putting together a decent view for the very small, the very minimal content that fits into the small screen of a smartphone. And then when you realize that the content, the screen is larger, that probably the class of the device is not the minimum you support, you dynamically download more HTML, more JavaScript, more CSS, and re-render the screen. I mean, creating a single page application that works this way, it's not exactly, it's a challenge. It's doable, sure. People are doing that, but it's not a child's game. It makes the experience of writing a website a totally different experience. and there's not much currently expertise. Single-page applications are a significant paradigm, change of paradigm. I mean, I've been trying to do single-page applications at the time in which they were called SDI, single document interfaces, 2007, 2008, and I just dropped. But not because it was hard to arrange the UI, but because of the side problems that come with single-page applications. Not much technical problems, but I would say usability problems. Because when you create a single-page application, and you are essentially telling your users, look, I'm going to give you an application that is so fast because it doesn't refresh for each action, for each interaction. And I'm giving you the feeling that you are working on a desktop app, except that it is delivered over the web. And it runs within the browser. But users used to work with browsers, they know that there are back and forward buttons. There is the F5 button to refresh the screen. They expect to be able to capture a link and share that link, and that link could be a deep link into some particular section or some particular page or functionality of the site. All of these things completely disappear by design when you turn to the single-page application model. So what today makes hard writing single-page applications is just the mix between the new and the old. The old classic web with all of the gestures, typical back, forward, F5, and the new web where you just create applications with the same request-response patterns of desktop apps, fixed static UI just updated for the delta that it takes to update given the last action over the web. Now, there are ideas, opinions, perspectives that try to put single-page applications in the direction that, well, this is a transition time. Maybe in a few years, half the people, or even more than half the people using websites will be younger. And so the generation of people who grew up, who learned how to browse using iPhone and smartphones. So people for which scrolling, indefinite scrolling is normal, and the people who get scared if they find a scroll bar and they have to click buttons to see more content. No, it's a gesture typical. You scroll, whether using the mouse wheel or the finger. You scroll, and when you reach the bottom, half the page automatically decides, reloads more content for you automatically. There's no need for scroll bars. That gives you an idea of how long the content is. And they probably never use back and forward. Deep linking, why deep linking? So it's just a different metaphor, the desktop versus the web. And single-page applications sit in the middle. So it's a way to build websites which go very well hand in hand with the mobile-first philosophy. But it's from the perspective of developers and team managers and architects, it's a challenge, a non-trivial challenge because of the expertise and because of the repercussions that you don't control. Because if your users don't like it because they expect to keep on using back and forward, and that's fundamental, you can tweak your single-page solution to make back and forward buttons work nicely. But it's a pain in the bacon. And now, responsive web design. So this is the mainstream, the most popular, even effective way of essentially having one set of HTML pages that the dynamic application of different CSS files can turn into different rendering of the content. The engine behind this methodology is CSS media queries, essentially conditional CSS style sheets. At the end of the day, CSS media queries look like link tags in the HTML page that point to CSS files, but there is with an extra attribute, the media attribute, which usually contains only words like screen, print, indicating the CSS to apply when you want to display or just print the content of the page. But this media attribute has been extended and to support Boolean expressions, similar to the where clause of SQL queries. So load this CSS where, and you can write there a Boolean expression that is based on up to 5 different values, the most important of which is the width of the screen. So this is conditional CSS style sheet. I will show you an example in a couple of moments, in a few moments. More importantly, CSS media queries are declared, and then they are automatically handled by browsers. So all you have to do is writing CSS and writing the conditional logic that turns them on or off. And only one CSS, the first one that matches, is selected at any time by the browser. In terms of responsive web design, media queries are the fundamental piece of the jigsaw, but it's not the only thing. There's more. There is just a grid-based approach to laying out the content. A grid-based is like the grid you have in XAML, if you are familiar with WPF and Windows Phone and Windows 8, Windows Store applications. So you imagine the screen split in like a matrix in blocks by rows and columns. And essentially, all you do with the CSS is indicating how many blocks need to be displayed horizontally so that the content, when the width gets smaller, automatically flow at the bottom of the content. So this is fluid grids, and also percentage-based sizes. So don't use absolute measurements. Maybe the only scenario where you want to use a specific number of pixels is for the minimum width of elements. But everything else that is not the minimum width of a div or a section is better expressed in terms of percentages of the width of the screen, so that they automatically resize when the user resizes the browser window, or the browser is full screen on a device that has a limited screen size. This is an example of how the media Boolean expression looks like. In particular, we are the first indicates that we are going to use View 480 CSS only when the page is being rendered for screen and the maximum width is 400 pixels. Max width is just one of those properties you can use that the browser understands. So it's part of the syntax, standard syntax of CSS media queries. And the other one is use instead view 800.css when the maximum width is 800 pixels. You put quite a few of them in the layout of the HTML page, in the master page, and then the browser will process them from top to bottom and stops at the first that matches the runtime conditions. And the selected CSS is applied. Easy and effective. This is the full list with the current standard of CSS, which is in the works. It's been updated to version 4, and a few more properties will make their debut sometime soon. But what I can tell you, none of the upcoming properties are such to really, revolutionize the things you can do, the power of responsive web design. So you have properties like device width and device height, which indicates the width and height of the physical device screen. Width and height instead indicates the width or height of the rendering viewport, the browser window. Now, the device width and width on mobile devices coincide, because on devices, every application runs full screen, so the two things essentially coincide. They are different instead on browsers, on desktop browsers, because the window can be resized. Orientation indicates whether the current orientation of the device is portrait or landscape. And that's interesting, because you can specify different CSS for when the page is viewed on a device in portrait or landscape mode. And I can tell you that even though I call myself a fan of server-side detection, so that recognize the device on the server and just send down, optimize the markup for that. So I'm kind of against. I'm not a big fan of responsive web design. No matter this, I tell you that sometimes it's really essential to change dynamically the CSS, the layout of the content between portrait and landscape, and responsive web design is the only way, effective way to make those changes, because it's not something you can order to the server, because it makes no sense that you detect, assuming that it's possible to detect the physical rotation of the device, send a request to the server to refresh the page. It has to happen on the client, and responsive web design is the most effective way of doing that. I've been doing this in a couple of websites, and it works beautifully. Then aspect ratio and device aspect ratio just indicates strings like 16:9. But okay, I think that there are also other properties, but yeah, the fundamental property for responsive web design are width and height, essentially, and maybe orientation. Okay, let me show you an example, a live example of responsive web design. It's not really a complex example, but it's good enough to show you how it works and to try to point out which are some of the most significant drawbacks. Okay, this is a page. Now the browser seems to detect the size of the window, and it tells me, well, this is my way of rendering content in desktop mode. But you see that as when I resize, it turns to tablet, and if I resize even more, at some point it gets a smartphone. It stays as a smartphone as I resize. And look that in this interval, you see the benefit of having proportional and fluid grids, because the size of this block has been deliberately set to be a fixed number of pixels. So you see empty space side of this block. But if you create, and that could be revolutionary, could be hard, if everything in the page is proportional, when you make a small, resize, still remaining in the realm of the smartphone view, you can have the entire content adjust slightly and fit better. Now, in responsive web design, the points, the pixel widths that set the change of CSS, so this width at the boundary there is called a breakpoint. It just is the width 800, 480, where you just change you switch the CSS file. But in between those breakpoints, everything else, stays. If you use fixed pixels for sizing elements, renders not optimally, and proportional just make everything adjusts to the effective size. So the difference is when you hit a breakpoint, you can change, you can make more significant changes. You can change something in the layout. You can hide things maybe, or you can position things differently. But in between breakpoints, proportional sizing is effective to render render the content in the best possible way. Now, a quick look at the code here. Okay, everything is in the master page, everything is in the site CSS. And site CSS has a bunch of blocks like this. They could also go to they could also go to this, could also go to separate CSS files or stay within the same CSS file. It doesn't really matter. And now, let me show you the code of the trivial HTML code of the page. As you can see, it has one div, one container, and 4 blocks: mobile, smartphone, tablet, desktop. Now, imagine that instead of a small, insignificant P tag, I have there a complex div block with all of the UI for the page. What I'm doing in this example essentially is, if we compare this to the CSS, is essentially changing, okay, colors, maybe the container width, but I'm essentially hiding and displaying blocks. CSS is great at styling things, but it is not a programming tool. It's easy to say, oh, well, I just apply a different CSS and the CSS just revolutionizes and makes my content render well on the new size of the screen. But which are the things that you can really do with CSS? You can certainly hide things. You can move things around with a float attribute. You can resize things. You cannot create, you cannot download different HTML, you cannot apply different logic. If you have to switch between different views which are physically different, so different HTML DOMs, everything needs to be downloaded in the beginning, and then just like a magician, something appears and something disappears. This wins, this loses. So the point that I want to try to make is that beyond the apparent magic of CSS, media queries, when you try to apply responsive web design principles to the building of websites that needs to be consumed effectively through devices, the problem, I mean, the problem of performance, bandwidth, download time, and usability go hand in hand. Because responsive web design tends you to, it does makes no difference between the device. It always downloads everything. And paradoxically, a complex site made with responsive web design, when run on devices, I mean, on the device, you download everything, the 3 megs, it takes the full page just to display a small chunk of it. You download to hide things. You download, okay, oh, well, I have a large image here, that I resize to fit nicely into a small device. Yes, you resize. So it renders well, but you still download a large image. So the point is, responsive web design, because it deliberately, by design, doesn't distinguish devices, it treats all devices the same way. Let me run for a moment This is now the same application that I showed a moment ago that is presenting smartphone view. Now, let me bring up the Internet Explorer developer toolbar, and let me change the user agent. Now, if I tell, look, you now are an iPad, it refreshed, but it's still there. So you say, oh, look, oh, nice. You tell me now you are an iPad. I couldn't care less. Because the size of the screen matches the display mode of a smartphone, you can be a smartphone, you can be a legacy device, you can be whatever you want. As long as the width is that, I couldn't care less. This is what you get. Instead, what we may expect is that, let me go to something, a website, a small site that I put on last night. Yeah, this now because I'm running the browser here, having the browser window sending to the web server the user agent of an iPad, and this sample page. Try that on your phones if you want. It's expoware.org/wurfel.js. That tells you, oh, look, you're a tablet. And you see that now, if I change, again, the user agent and say, look, you are now a Windows phone, it tells me, oops, you're a smartphone. This is device detection. You don't get this with responsive web design. Now, in the company I run, and we make a business out of providing websites for customers, as probably most of you do. So we do use responsive web design. It's probably still the quickest way to provide something that decently renders out on a variety of devices. But when the website is particularly critical, we stop using responsive web design, and we just find out different approaches that I'm going to discuss in 3 moments that is based on effective device detection, and subsequently, we switch HTML views instead of switching CSS files. And it's easy. Why? What's the difference between switching a view and switching a CSS file? Because a view means HTML, JavaScript, and also CSS. You decide what to render. And you can have a completely different rendering on tablets, mini tablets maybe, and smartphones and PCs. You decide. With CSS, you are limited in what you can do. You can, at the most, hide or resize things. OK, back to PowerPoint for a few more slides. So the question is, where does mobile fit in responsive web design? The answer is simple. It doesn't fit. Wow. Disappointment. It's not disappointing. Responsive web design was, created to address desktop sites. That it was such a successful and smart approach that it could be adapted to serve at really low cost the needs of devices. But my point here is not selling you other libraries or other approaches for server-side detection. The fundamental issue is, look, you can be using responsive web design, can be happy. But that's only half the scenarios and the options you have. You are missing some important points. Maybe you can intelligently look at those points and determine that, okay, we couldn't care less. Those extra points are not important to us. We're happy with responsive web design. Fine. But at least you know. So, why? Let's put for a moment responsive web design aside. And let's look into alternatives. Why? When we speak server-side solution, server-side detection of devices, the idea is the browser makes a request. The web server understands the characteristics of the device making the request, and server-side, your ASP.NET MVC, web forms, PHP, whatever, website, understands that and uses, a switch, logical switch statement, and serves the best HTML view. Well, it's, a clean way of reasoning, but it has a hurdle. How would you do device detection? Now, there is just one way, one only common piece of information that server-side applications can rely to try to guess more about the characteristics of the requesting device. This kind of thing, which is precisely what scares people, most, some, many, about server-side solutions, is this: the user agent string. It's nearly not intelligible, not for humans. Now, a string like this tells nearly everything to ad hoc tools, but it tells nearly nothing to humans. So now, who's gonna parse this string? You, me, tools? It depends on what is my purpose. If I'm mostly okay with responsive web design, and I only want to give a different experience only to some users of some phones, one thing I can do is capture the user agent of browsers on those phones, and if the request.userAgent matches that string, I do something different. Yeah, but that means that I have to continuously, add strings. Oh, okay, it could be a separate database. It could be a separate XML file. So you can find ways to manage these kind of things. But you end up having a sort of personal dictionary where the key entry is the user agent and the value entry is, I don't know, a JSON object with the capabilities, or maybe just the name of the view to use in that case. This works. But you will realize that the number of user agent strings that you want to handle differently may grow over time significantly. As developers, we want to be smart. And then we can think, okay, but at the end, I just want to offer a different experience to iPhone or iPad devices. And probably if you look at the user agent for iPhones and iPads, you find in this mess the substring iPad or the substring iPhone. And you can reasonably sure that if you find iPhone or iPad in a user agent, that is an iPad or an iPhone. Well, that's nice. Better way to do. But if you want to focus on Android, just the fact that you find Android in a user agent means nothing. An Android could be a tablet like this, which is a Galaxy Tab. Or it could be my daughter's mobile phone, something like this. It could be everything. So it depends on what is your goal. Just detecting iPhones? Just detecting maybe Windows phones? But even Windows phone, iPhones are more or less, the features are common. If it's an iPhone, you can be more or less sure that it's the same device. iPhone 5s are larger, but you can. But with a bit of responsive web design in the view you send, you can probably work that out. But Android means nothing. Even Windows Phone. One thing is Windows Phone 7, the first version. Which had a browser that basically could only render HTML and nothing more. You cannot even call that a smartphone. I mean, I was an advisor on a patterns and practices group at Microsoft a couple of years ago, where they were just trying to create a pilot project on how to do mobile-oriented websites. And they used the technology I'm going to present now to layer the device recognition. And they decided they put Windows Phone 7 not in the smartphone layer. It's not a smartphone. Because the browser, simply judging the browser capability, right? The browser was capable of doing nothing, the first Windows Phone. So that it's a Windows Phone tells you not enough information about the things you can do, about the features you can render. So it's all about user agent strings and the ability to serve intelligent markup. Okay, now, this is another project that uses, it's an MVC app, but it uses a library called Würfel to do device detection server-side. So it's an application that processes, has an API to process the user agent string and returns an array of capabilities indicating things that the detected device can do. So what I did is creating a sort of view switcher within the application that detects the device and routes to the most appropriate view. Here's how it works. It detected that the site is being visited using a desktop browser, and it says, look, I'm sorry, this website is not available on desktop browsers. Try using a mobile or tablet. So this is not an error page. This is exactly, in the context of the demo, the expected result. Now, let me bring up again the developer tool, and let me change the user agent to an iPad. Instantaneously, you see that the UI changes to be the UI specifically designed for a tablet. And you see that if I resize this to what could be possibly the size of a smartphone, it still keeps on showing me the tablet UI because it's rendering mechanism is driven by the user agent string, which has not changed yet. But as I change the user agent to that of, I don't know, Windows Phone, oops, let me refresh. It now shows me what could be the same content rendered for a smartphone. And if I, if I change this to a custom user agent, and in particular this one, which is a very old phone, This is what I get, yet another view, okay, for a very, a legacy kind of device, and even simpler user interface. So I'm having here, out of the same, just the same MVC website, 4 different views: legacy, smartphone, tablets, desktop. It's not that it's not 4 different websites. It's one website, one set of controllers, just different views, just different Razor files. And let me show you how it works concretely. So the first thing you do, by the way, this is an MVC, I think 5 application, but it works. It has been ported from MVC 4. It is using a feature of MVC that is not available before version 4. So if you want to use this trick in MVC 3 applications, you have to contact me if you want to take the shortest path. I can give you a DLL that simulates in MVC 3 what has become a built-in feature of MVC with version 4. This feature is called display modes. Display modes work in the following way. Let's start from Globalize X. And in Globalize X, you see a couple of extra lines. One is to initialize the Wurfel library for device detection. And more importantly, you have the configuration of display modes. Display config is my class. Display mode provider instance modes is the internal to MVC collection that takes note of the available display modes for the current site. So what I do here in this custom method register display modes is telling the runtime about the display modes I want to support. And I want to, in each display mode is characterized by 2 things. A suffix, which is the suffix we use to identify specific Razor files views, which is the empty string for desktop, is smartphone, tablet, or legacy for others. These are just strings, okay? As long as they are unique, they are arbitrary. These are just the strings you will use to suffix Razor files to indicate for the view called generically index, what is the smartphone view of the index view, what is the legacy tablet, and so forth. And the second parameter you have in a display mode object, beyond the suffix, is the context condition, which is the Boolean expression that decides whether, given the requesting HTTP context, whether the given display mode applies. So essentially what I'm doing here is, so the context condition is a lambda expression which takes the HTTP context and returns a Boolean. So you have everything, you write your code in the lambda, you put any code you like that can process the HTTP context of the incoming request. So it has a full access to HTTP headers, full access to the user agent, and probably, maybe cookies, the query string, whatever. And you, based on that, decide whether the display mode that you created applies or not. So if the isDesktop extension method, my custom code in the project, if the logic applied to the request object determines that this is the desktop, I return true. If it detects to be coming from a smartphone, tablet, or legacy, I return true. So this is the list of display modes. This is the definition. I have to add display modes to the system collection. So now, when the Globalize X runs, I have a system that knows how to detect smartphones, tablets, legacy, and desktop devices. Let me now this is mostly done, in the sense that the only key thing to look at is how smartphone is implemented. As I told you, smartphone, is desktop, and so forth. Those are extension methods on the HTTP request base class. Is smartphone internal? This uses Wurfel, this extra library. Wurfel is available for .NET, for ASP.NET as a NuGet package. So it couldn't be easier to plug into your application. And yes, when you initialize Wurfel, here, all you do, you need just a single line of code that essentially reads from the config file where you have the Wurfel database of devices, because when you install NuGet, you get a database of devices, and then you get the API, a couple of DLLs. The database of devices needs to be placed somewhere. Typically, it goes in the app data folder. It's a zip file that goes in the app data folder. And OK, you get this out of NuGet. If you want updates, you need to apply for a commercial license with a company who develops Wurfel, and you can get weekly updates to the zip files. There's another alternative API, which is cloud-based. And in the cloud-based solution, you have elastic number of capabilities you can get. And at least for the two basic capabilities, it's even free. You have to register, but it's free for two capabilities, which basically tells you it's mobile or not generically. And also you have issues with the hit counts, hit requests, whatever. But it's cloud-based, so you decide how much you spend. So this is the premise, the on-premise approach, but there is also a cloud-based solution. OK, fine. Back here, smartphone internal receives a user agent string and just calls the Wurfel entry point and call getMadeDevice for this request. And then it gets an iDevice object, and that you can query with a bunch of, isTouch, has OS. These are extension methods I wrote myself to make the whole code more readable. But there's an API, not that nice probably, but there's an API that you can use. And then, for example, a smartphone is a device that is wireless but is not a tablet. It has touch capabilities. Width is at least 240, and the operating system is Android at least version 2.1, iPhone version 3.2 at least, Windows Phone OS at least 7.1, maybe RIM OS, and this is your code, okay? So the definition of what is a smartphone is up to you, ultimately. So whether a device is a tablet or not is more of a general statement. What you consider a smartphone is, in a way, application-specific. This is a piece of code that I borrowed from the source code of Wurfel, which is open-sourced anyway. And they use a logic very similar to this one to determine what makes a smartphone. But maybe you can have your own requirements. You know that your app is very hungry of resources, and maybe you know that it doesn't work on Windows Phone, maybe, so you can just drop this line, or you can require at least iPhone 4. But you decide, what is a smartphone given your specific application context. The Wurfel library offers a default implementation of the algorithm that determines a smartphone. But you can change that by writing, essentially, your own code and mixing that with display modes. Just to give you an example of the real API of Wurfel, this is the implementation of the iDevice extension, and this is how it works. Is tablet, the API, the native API is based on a method called getCapability. The list of capabilities are in the documentation of Wurfel on their website. And each capability has a string name, and by design, always return a string. So it's a string to string. So I'm using other custom methods to turn, strings to Boolean, integers, whatever. And for example, for touch, this is the API. There's a pointing method capability. If that equals touch screen, you know that the device is known to have touch capabilities. Now, it's known to be. One of the points that sometimes scare people about server-side detection is that you don't do real detection, but you kind of guess. So the list of capabilities is capabilities that can be, inferred from the user agent. The user agent is mapped to a predefined device profile, and each device profile is known to have certain capabilities. So it's a kind of guess, but it couldn't be done if you think about that otherwise. And if you find a better way, let us know. Anyway. OK, now, there is something more. This is the server side. But this is a slide that I wrote just this morning, because this is an announcement that came up Monday at the Mobile World Congress in Barcelona. The company behind Wurfel just made available, and this is free, no strings attached, it's completely free, created a Wurfel.js JavaScript file. So this is the URL, http://wurfeljs.com/wurfeljs, and this is the script code you need to have. If you place this code into your pages, you're going to get injected in the page a JSON object like this, with 3 properties: complete device name, is mobile, true, false, and form factor. So to be precise, you're going to have something like this. It's var Wurfel equal. You guess what? You can now use the Wurfel JavaScript object in your in your HTML page manipulated via JavaScript to detect the form factor of the device. And form factor returns strings like desktop, smartphone, smartphone, tablet, smart TV, robot, app, if you're connecting from an app, and a few others. The documentation is on wurfeljs.com. And the page that I showed earlier, this is the wurfeljs.com website where you can find more information. It's also instructive to look at the source code of this page, which uses wurfeljs.com, the JavaScript library internally. So take a look at that. And the sample page I put up earlier, expower.com, this one here. This is based on Wurfel.js. And the string that you see here is exactly the value of the form factor string. I can probably show you the source code of this page up here. Yep, you see that there is this. And and all I do is in document ready, I just okay, we try to bring this up in a more visible way. Where is the notepad? Okay, so this is the code that I'm using there to update the title of the page, Wurfel.formFactor. And in action, it does precisely this kind of things. F12 again. If I change the user agent to be, okay, this is still desktop, Internet Explorer 10. But if I go to Xbox 360, if I pick Xbox One, still desktop. Okay, I'm sorry. I worked with a beta version which was more precise about recognition. Oh, okay, by the way, is this correct? Okay, yes. If I... That's something that doesn't work here. Maybe I'm doing something stupid. I'm probably doing... Yeah. No, there's some... No, I think, maybe I'm doing something stupid, maybe with F12 that doesn't refer to this. Let's see. I don't know. Maybe I think that this is probably there's some issues with the F12, but you saw that working earlier. So I mean, it's probably something that it's out of my control. And also a way to remind me that the time is enough. Anyway, feel free to play with Wooful.js. It's free, so. It could be interesting to work. It still remains as a client-side solution, however. So it works probably much better if you have a single-page application, because it gives you the power to detect the device and then decide how to arrange, intelligently the markup. It's not a shortcut. A free shortcut to have device detection done on the server, and doing server-side detection on the server is the most efficient way because it allows you just to optimize the bandwidth, and that's the key point. So server-side detection is great because it allows you to control how much HTML you send down to the client. It tells you whether the requesting device is powerful, not so powerful device or not, so you can decide how much to send, and you can send HTML that delivers to the user what you think is the best experience for them. So usability and performance together, low cost in terms of bandwidth, maximizing the usability. This is the difference between responsive web design, which is a common denominator solution, and something more specific like server-side detection. And Wooful is not the only one, not the only framework out there, but it's the de facto standard. And 3 names that use Wooful: Facebook, Google, PayPal. And just in case you don't do .NET only, Wooful is also the only one cross-platform. So you find similar library for Java, for PHP, for C++, and so forth. OK, that's it. Nobody can afford slow mobile pages. Be specific, server fast. Thank you very much for your time. I hope you find this helpful. Thank you.